Did you know that every atom in your body was forged inside the nuclear furnace of a dying star billions of years ago? You are literally made of stardust that has traveled across the galaxy for eons before becoming part of you. Carl Sagan wasn't being poetic when he said, "We are made of star stuff." He was stating a profound scientific truth that connects every human being to the cosmos in the most intimate way possible. But here's what will blow your mind. Do you know which elements in your body came from the most violent explosions in the universe? The discovery that shocked astronomers. Alarms started blaring at observatories across 3 continents when the data came in. Something massive was barreling through our solar system, and it wasn't supposed to be there. Just weeks ago, the most sensitive gravitational wave detectors on Earth picked up an anomaly that made veteran astronomers do double takes at their screens. This wasn't your typical asteroid or comet announcement buried in some obscure scientific journal. This was an emergency alert that had space agencies scrambling to redirect their most powerful telescopes toward a single point in space. The object's gravitational signature was so pronounced that it actually bent the trajectory of nearby space debris, creating a cosmic wake that screamed, "I'm here," to anyone paying attention. What really sent shockwaves through the scientific community wasn't just the size. Though at 10 times larger than Oumuamua, it's absolutely colossal. But the timing. 2 interstellar visitors in less than a decade defies every statistical model we have about these cosmic wanderers. The discovery team at the European Southern Observatory couldn't believe their instruments at first, running diagnostics 3 times before accepting what they were seeing. Unlike Oumuamua's stealthy approach that caught us completely off guard, this behemoth announced its presence like a cosmic freight train, giving us unprecedented advance warning, and the chance to study an interstellar visitor while it's still approaching rather than racing away from us. Size comparison. What if I told you that right now, something the size of Manhattan is silently cruising through our solar system at 26 kilometers per second? This new interstellar visitor makes Oumuamua look like a pebble next to a skyscraper. We're talking about an object so massive that if you placed it next to the Empire State Building, the building would look like a toothpick. To put this in perspective that'll blow your mind, Oumuamua was roughly 400 meters long, about the length of 4 football fields. This new cosmic giant? We're looking at something approaching 4 kilometers in length. That's not just big, that's monumentally huge by space rock standards. The sheer volume difference is staggering. You could fit over 1,000 Oumuamuas inside this thing and still have room left over. When astronomers first calculated its dimensions, they had to recalibrate their instruments because the readings seemed impossible. This isn't just another space rock drifting through the void, this is a cosmic mountain, a wandering piece of another star system that somehow found its way to our neighborhood. The gravitational influence alone is enough to slightly alter the orbits of smaller asteroids in its path. If Oumuamua was nature's postcard from another star system, this new visitor is like receiving an entire encyclopedia. The amount of data we can gather from something this size could revolutionize our understanding of interstellar objects and the distant worlds they come from. We're witnessing something that happens maybe once in a human lifetime. The trajectory mystery. Every computer model says this shouldn't exist, yet here it is, defying the laws of celestial mechanics as we know them. This massive interstellar wanderer is following a hyperbolic orbit so extreme that it's rewriting textbooks on how objects move through space. Unlike anything in our solar system that follows predictable elliptical paths around the sun, this cosmic giant is on a one-way ticket to nowhere, traveling on a trajectory that screams, "I'm not from around here." What's absolutely mind-bending is where it came from. Deep space analysis suggests this visitor originated from a stellar region over 100 light-years away, meaning it's been traveling through the cosmic void for potentially millions of years before stumbling into our neighborhood. The orbital mechanics team at NASA had to create entirely new calculation models because this object's path doesn't match any known gravitational influences in our solar system. It's approaching from an angle that suggests it came from the direction of the constellation Lyra. But here's where it gets really weird. Its velocity and trajectory indicate it may have been gravitationally slingshot by multiple star systems during its epic journey across the galaxy. The precision of its path is so mathematically perfect that some scientists are questioning whether this could be natural at all. This isn't just a random space rock that happened to wander into our solar system. This is a cosmic bullet fired from the depths of interstellar space with surgical precision, following a trajectory that will take it past our sun and back out into the infinite darkness of deep space. Composition secrets revealed. Scientists just discovered something that's making them question everything they thought they knew about space rocks. This interstellar giant isn't made of what it should be made of. When the first spectral analysis data came back from the Hubble Space Telescope, the research team stared at their screens in complete bewilderment because the light signatures were unlike anything in our cosmic catalog. This massive visitor is reflecting sunlight in patterns that suggest a composition so bizarre it's forcing astronomers to rewrite the periodic table of space objects. The surface appears to be a patchwork of materials that shouldn't exist together. Metallic compounds mixed with crystalline structures that only form under extreme pressure conditions found in the cores of dying stars. What's absolutely fascinating is that different sections of the object are showing completely different spectral signatures, as if it's a cosmic Frankenstein monster assembled from the remnants of multiple stellar systems. The infrared readings reveal temperature variations across its surface that indicate some areas are absorbing heat while others are reflecting it, creating a thermal map that looks more like abstract art than natural geology. Most shocking of all, there are regions showing traces of rare earth elements that are virtually impossible to find in natural asteroids, leading some researchers to wonder if we're looking at processed materials rather than raw space rock. The chemical fingerprint is so unique that it's like nothing we've ever encountered in our solar system, suggesting this wandering giant carries the geological history of alien worlds within its very structure. The acceleration anomaly returns. Houston, we have a problem, and it's accelerating when it absolutely shouldn't be. Just like Oumuamua's infamous speed boost that left scientists scratching their heads, this colossal interstellar visitor is pulling the exact same impossible stunt, but on a scale that's making physicists lose sleep worldwide. As this massive object approaches our sun, it's gaining velocity in ways that completely violate our understanding of orbital mechanics, speeding up without any visible propulsion system or outgassing that could explain the acceleration. The numbers are absolutely staggering. We're talking about a 4-kilometer-long object somehow adding an extra 0.3 kilometers per second to its velocity, which in space terms is like a freight train suddenly sprouting rocket boosters. What's driving the scientific community absolutely crazy is that this acceleration is happening in a perfectly controlled manner, not the chaotic bursts you'd expect from natural phenomena like comet outgassing or solar radiation pressure. The trajectory calculations show this speed increase is so precise, it's almost like someone is gently pressing the accelerator pedal on a cosmic spacecraft. Multiple observatories have confirmed the readings, ruling out measurement errors, which means we're witnessing something that challenges the fundamental laws of physics as we know them. The most unsettling part, the acceleration pattern is nearly identical to Oumuamua's, suggesting these interstellar visitors share some mysterious propulsion mechanism that we simply don't understand. Two objects separated by years and vastly different in size, both exhibiting the same impossible behavior. Coincidence or something far more extraordinary? Why scientists are freaking out. The coffee machines at observatories worldwide are working overtime because astronomers can't sleep, and for good reason. Two massive interstellar objects visiting our solar system within a single decade has shattered every statistical model we've relied on for predicting cosmic events. According to our best calculations, we should see maybe one interstellar visitor every few thousand years, yet here we are with two giants that have decided to drop by for a cosmic house call in what amounts to a cosmic blink of an eye. The probability of this happening naturally is so astronomically low that it's like winning the lottery while being struck by lightning during a solar eclipse. What's keeping scientists awake at night isn't just the timing, it's the eerie similarities between these visitors that suggest we might be witnessing the beginning of something unprecedented in human history. Research teams are frantically revising their models of interstellar object frequency, and the new numbers are painting a picture that nobody expected. Some leading astrophysicists are quietly suggesting that our galaxy might be far more crowded with wandering objects than we ever imagined, or worse, that something is actively sending these massive visitors our way. The European Space Agency has already fast-tracked 3 emergency research projects to study this phenomenon, while NASA is redirecting resources from other missions to focus entirely on these mysterious wanderers. The scientific community is buzzing with theories ranging from natural galactic cycles to artificial intervention. But one thing is certain, our understanding of the cosmos just got turned completely upside down. The alien technology debate. So, what happens when the world's most respected scientists start whispering about artificial intelligence in the hallways of Harvard and MIT? The arrival of this second massive interstellar visitor has, honestly, reignited the most controversial debate in modern astronomy. Are we looking at natural space rocks or, something far more extraordinary? While the scientific establishment tries to keep their professional composure in public, behind closed doors, heated discussions are erupting about the possibility that these objects might actually be probes from distant civilizations. The timing, the similar acceleration patterns, and those bizarre compositions are creating a perfect storm of evidence that's making even the most skeptical researchers question their assumptions. Dr. Avi Loeb, the Harvard astrophysicist who famously suggested Oumuamua could be artificial, is now pointing to this new visitor as potential confirmation of his theories. The mathematical precision of both objects' trajectories, combined with their inexplicable acceleration, is displaying characteristics that, well, some argue are more consistent with engineered systems than with natural phenomena. What's particularly unsettling is how both visitors seem to be following optimal paths for maximum solar system observation. Almost as if they're conducting a systematic survey of our cosmic neighborhood. The scientific community is split between those desperately seeking natural explanations and a growing minority who believe we might be witnessing humanity's first contact with extraterrestrial technology. Government space agencies are, for now, remaining diplomatically silent, but insider reports suggest classified meetings are happening at the highest levels to discuss the implications of what we might actually be observing. What makes this one different? While Oumuamua played cosmic hide-and-seek with us for just a few months before vanishing into the void, this colossal newcomer is giving humanity the ultimate gift: time. Unlike its predecessor's lightning-fast flyby that left scientists scrambling to gather data before it disappeared forever, this massive interstellar giant's sheer size and trajectory mean we'll have an unprecedented window of opportunity to unlock its secrets. The difference is absolutely game-changing. Where Oumuamua was like trying to photograph a speeding bullet in the dark, this new visitor is more like having a slow-moving freight train that we can study from every conceivable angle. Space agencies worldwide are treating this as the scientific opportunity of a lifetime, with multiple nations already announcing emergency funding for dedicated observation missions. The European Space Agency has fast-tracked 3 separate probe launches, while NASA is retrofitting existing satellites to focus exclusively on this cosmic wanderer. What's particularly exciting is that this object's size means we can use ground-based telescopes to gather detailed surface mapping data that was impossible with Oumuamua's smaller profile. The extended observation period will allow us to track seasonal changes, monitor its mysterious acceleration patterns over months rather than weeks, and potentially solve the riddle that has haunted astronomers since 2017. This isn't just another interstellar visitor, it's our cosmic Rosetta Stone, offering the chance to finally understand what these mysterious wanderers really are and where they come from in the vast expanse of space. The timeline. Mark your calendars because humanity is about to witness the cosmic event of the century, and missing it would be like skipping the moon landing all over again. This interstellar behemoth is currently racing toward its closest approach to our sun, scheduled for the coming months, creating a once-in-a-lifetime opportunity that won't repeat for potentially thousands of years. The timeline is absolutely perfect for maximum scientific observation. We're talking about a cosmic alignment that astronomers could only dream of just decades ago. As this massive visitor swings around our sun in what scientists are calling the golden observation window, it will be positioned for optimal viewing from Earth-based telescopes and space-based instruments simultaneously. The approach trajectory means that for several weeks this object will be close enough for detailed surface analysis while still far enough away to observe safely without solar interference. What makes this timeline even more extraordinary is that the object's path will take it through multiple optimal viewing zones, giving different regions of Earth prime observation opportunities at different times. Amateur astronomers with decent telescopes will actually be able to spot this cosmic giant during its closest approach, making this a truly democratic space event where professional scientists and backyard stargazers can participate together. The European Southern Observatory has already released viewing schedules for the public, while NASA is planning live streaming events to share real-time data as it comes in. This isn't just a scientific milestone, it's a moment when all of humanity can look up at the same cosmic visitor and wonder about the mysteries of deep space together. What this means for humanity. Every generation gets one moment that fundamentally changes how we see our place in the universe, and we're living through ours right now. These massive interstellar messengers aren't just cosmic curiosities floating through space. They're revolutionary time capsules carrying the geological fingerprints of alien worlds that existed billions of years before Earth even formed. Each of these wandering giants represents a direct physical connection to star systems so distant that their light takes centuries to reach us. Yet here we are, able to touch their surfaces with our instruments and decode their ancient secrets. The implications are staggering. We're essentially conducting archaeology on objects that have witnessed the birth and death of countless stars, survived supernovas, and drifted through the cosmic void while carrying pristine samples from the far reaches of our galaxy. What makes this discovery truly transformative is that it's shattering our cosmic loneliness, proving that our solar system isn't an isolated island, but rather a busy intersection in a galactic highway filled with wandering worlds. The data we're gathering from these visitors is rewriting textbooks on planetary formation, stellar evolution, and the very nature of how matter moves through space. Future generations will look back at this moment as the turning point when humanity first began to understand that we're part of a dynamic, interconnected cosmic community where worlds regularly exchange materials across impossible distances. These aren't just space rocks, they're ambassadors from the deep cosmos, offering us our first real glimpse into the true nature of our galactic neighborhood. That's a wrap on another mind-bending journey through the cosmos. These interstellar visitors are just the beginning of what promises to be an incredible era of space discovery. What do you think? Are we witnessing natural phenomena or something far more extraordinary? Drop your wildest theories in the comments below because I absolutely love reading your thoughts. If this cosmic mystery fascinated you as much as it did me, smash that subscribe button, and don't forget to hit the bell icon so you never miss our latest space revelations. Until next time, keep looking up and questioning everything. This is Simply Science, and we'll see you in the next video. Jupiter isn't just the largest planet in our solar system, it's a cosmic monster hiding secrets that could rewrite physics textbooks. While we've admired its colorful bands for centuries, NASA's Juno spacecraft discovered something absolutely terrifying. Perfectly organized storm systems that shouldn't exist, mysterious ammonia towers stretching thousands of kilometers high, and a great red spot that's dying faster than scientists ever predicted. But here's the kicker. Jupiter might be more alien than we ever imagined. Did you know Jupiter's magnetic field is so chaotic it would instantly kill any human who got too close? The mystery storm discovery. Scientists expected chaos when Juno peered into Jupiter's depths, but what they found was far more unsettling. Perfect order where none should exist. Hidden beneath the planet's familiar bands are storm systems arranged in geometric patterns so precise they look engineered. These aren't random weather events, they're mega-cyclones that have been spinning in formation for potentially millions of years. Dr. Alberto Adriani, from the Institute for Space Astrophysics in Rome, describes them as impossible structures that violate everything we know about fluid dynamics. The storms maintain perfect spacing, like gears in a planetary machine, each one larger than Earth and more powerful than anything in our solar system. What's keeping them organized? Why haven't they merged or dissipated like normal storms should? Juno's data suggests these formations extend thousands of kilometers deep, powered by energy sources that remain completely unknown. The geometric precision is so unnatural that some researchers privately wonder if they're witnessing the remnants of some ancient cosmic event that fundamentally altered Jupiter's atmospheric behavior. Each storm rotates with mathematical precision, creating a pattern that defies the chaotic nature of fluid mechanics. Steeple Mountain discovery. Deep beneath Jupiter's swirling surface, Juno's microwave radiometer detected something that shouldn't exist. Towering structures of ammonia rising like ghostly skyscrapers through the dense atmosphere. These steeple mountains stretch 3,000 kilometers high, making Earth's tallest peaks look like pebbles. But here's the terrifying part. They are not solid. These are fluid towers, streams of superheated ammonia shooting upward at velocities that would tear apart any earthly structure. Dr. Scott Bolton and his team at NASA's Jet Propulsion Laboratory initially thought their instruments were malfunctioning. How could liquid structures maintain such height in an environment where pressure should crush everything? The discovery suggests Jupiter's interior is far more turbulent than anyone imagined, with convection currents powerful enough to launch material thousands of kilometers upward. These aren't isolated events. Juno has detected dozens of these formations, some persisting for months, while others appear and vanish like cosmic mirages. The ammonia plumes carry with them traces of deeper materials, offering glimpses into Jupiter's mysterious core regions where temperatures exceed 20,000 degrees Celsius. What force is driving these massive eruptions from Jupiter's depths? Largest eruption recording. On March 15, 2021, Juno witnessed Jupiter unleash its fury in ways that left scientists speechless. What started as routine atmospheric monitoring became documentation of the most violent planetary eruption ever recorded. Material exploded from Jupiter's depths at 150 meters per second, creating a shockwave that rippled across the entire hemisphere. This wasn't just a storm, it was a planetary convulsion that ejected enough material to bury Texas under 10 meters of debris. The eruption originated from pressures 100 times greater than Earth's surface, in regions where the atmosphere becomes so dense it behaves more like liquid metal than gas. Juno's instruments recorded temperature spikes exceeding 2,000 degrees Celsius, as the explosion tore through atmospheric layers that had remained stable for centuries. The sheer violence of the event suggests something catastrophic occurred in Jupiter's deep interior. Perhaps the collapse of a massive atmospheric structure, or the release of energy that had been building for decades. What's most disturbing is that this might not be rare. Analysis of Juno's 4-year dataset reveals smaller versions of these eruptions occurring regularly, like a planet-sized pressure cooker releasing steam. Each eruption carries chemical signatures from depths no spacecraft has ever sampled, offering terrifying glimpses into the hellish conditions that exist within our solar system's largest world. Jupiter's magnetic field. Forget everything you thought you knew about planetary magnetic fields. Juno's magnetometer revealed that Jupiter's magnetic environment is a chaotic nightmare that would instantly kill any unprotected visitor. Instead of the simple, predictable dipole field scientists expected, Jupiter possesses a twisted, lumpy magnetic field that defies all theoretical models. In some regions, the field's strength reaches 20 times Earth's intensity, while in others it nearly vanishes completely. Dr. Kimberly Moore at Harvard University describes it as magnetic chaos on a planetary scale. The field's bizarre structure suggests Jupiter's core isn't the solid, well-organized sphere scientists assumed. Instead, it appears partially dissolved, creating a churning metallic hydrogen dynamo that generates magnetic mayhem. This chaos extends millions of kilometers into space, creating radiation belts so intense they would cook electronics instantly and deliver lethal doses to humans in seconds. Juno itself barely survives each close approach, with its instruments shutting down to prevent damage from the crushing radiation. The magnetic field's unpredictable nature also means Jupiter's moons experience wildly varying radiation exposure as they orbit. Europa and Io are constantly bombarded by charged particles accelerated to near-light speeds, creating auroras visible from Earth but also sterilizing their surfaces with deadly efficiency. Atmospheric water mystery. Here's where Jupiter's story takes a sinister turn. Juno's near-infrared spectrometer was designed to map Jupiter's water content, but instead it discovered something far more unsettling: massive regions where water mysteriously vanishes. According to planetary formation theory, Jupiter should be rich in water vapor, yet Juno found vast dry zones where H2O readings dropped to nearly zero. Dr. Chung Lee at the University of California, Berkeley calls it the missing water problem, but the implications are far more disturbing than the name suggests. Something is actively consuming or hiding Jupiter's water and scientists have no idea what. The dry zones aren't random. They appear in organized patterns that correlate with the planet's mysterious deep storm systems. In some regions, water abundance fluctuates wildly over timescales of hours, as if something is feeding on it in massive gulps. Chemical analysis reveals traces of exotic compounds that shouldn't exist in Jupiter's supposed water-rich environment. These mysterious substances appear wherever water disappears. suggesting some unknown chemical process is converting H2O into unidentifiable products. The water mystery gets worse the deeper Juno looks. Pressure levels where liquid water should be abundant show the most extreme depletion, hinting that whatever is consuming Jupiter's water prefers the high-pressure environments deep within the planet. Polar cyclone dynamic. Jupiter's poles revealed a site so perfectly organized it seems almost artificial. Geometric arrangements of cyclones that have maintained their formation for over 8 years since Juno's arrival. The North Pole hosts 8 cyclones arranged in a perfect octagon around a central storm, while the South Pole displays 5 cyclones in a pentagon formation. Each of these storms is larger than Earth, spinning at velocities exceeding 350 kilometers per hour, yet they never merge or drift from their positions. Dr. Alberto Adriani from Italy's National Institute for Astrophysics describes the formation as geometrically impossible according to known atmospheric physics. The cyclones maintain precise spacing like dancers in a cosmic ballet, each one feeding off the others in ways that shouldn't create stability. What's most unnerving is their persistence. These storms have shown no signs of weakening or changing position, despite the chaotic nature of Jupiter's atmosphere. Computer simulations attempting to recreate these formations consistently fail, suggesting fundamental gaps in our understanding of atmospheric dynamics. The cyclones rotate in alternating directions, creating a complex system of vortex interactions that generates its own weather patterns. Deep within each storm, Juno detected temperature anomalies and chemical signatures that differ from the surrounding atmosphere, as if each cyclone is connected to different regions of Jupiter's interior through unknown mechanisms. Jupiter's composition and structure. Juno shattered every textbook description of Jupiter's interior structure, revealing a planet that assembled itself using rules we don't understand. Instead of the neat, layered structure scientists expected, Jupiter possesses a fuzzy core that extends halfway to the surface, a discovery that invalidates 50 years of planetary formation theory. Heavy elements like silicon and iron, which should have settled into a compact central core, are instead mixed throughout the planet in impossible concentrations. Dr. Tristan Guillot from the Côte d'Azur Observatory describes Jupiter's interior as dilute core soup, a churning mixture where rock, ice, and metallic hydrogen swirl together in ways that violate basic principles of planetary differentiation. The implications are staggering. If Jupiter formed differently than we thought, then our entire understanding of solar system evolution is wrong. Gravitational measurements reveal density variations that shouldn't exist, suggesting Jupiter's interior is constantly reshuffling itself through unknown mechanisms. Temperature gradients detected by Juno indicate heat sources distributed throughout the planet rather than concentrated at the core, challenging fundamental assumptions about how giant planets generate energy. The fuzzy core discovery also explains why Jupiter radiates 2.5 times more energy than it receives from the Sun. It's essentially a failed star still contracting and generating heat through gravitational compression, but in ways far more complex than scientists ever imagined. Great Red Spot Analysis. The Great Red Spot isn't just Jupiter's most famous feature, it's a window into the planet's terrifying depths. Juno's close-up analysis revealed this iconic storm extends 300 kilometers deep, with routes that may connect directly to Jupiter's core regions. But the most disturbing discovery wasn't its depth, it was what's keeping it alive. The spot's distinctive orange-red color comes from complex organic compounds that shouldn't exist at those atmospheric pressures and temperatures. Dr. Amy Simon at NASA's Goddard Space Flight Center describes these chemicals as atmospheric ghosts, substances that appear and disappear in ways that violate known chemistry. The storm isn't just spinning randomly, it pulses with a rhythm like a planetary heartbeat, expanding and contracting in 87-day cycles that seem connected to Jupiter's rotation period. Juno's data reveals the Great Red Spot is actually hollow at its center, creating a massive atmospheric vortex that acts like a planetary drain. Material gets sucked into this central void and disappears into Jupiter's depths, carrying surface chemicals into regions where they undergo unknown transformations. Most unsettling of all, the storm shows signs of intelligence. Its behavior changes in response to external stimuli, almost as if it's aware of Juno's presence. The Great Red Spot has survived for over 400 years by feeding on smaller storms, absorbing their energy and growing stronger, like an atmospheric predator that dominates Jupiter's weather systems. Jupiter as planetary protector. While Jupiter protects Earth from cosmic debris, Juno revealed this protection comes at a horrifying cost to anything that ventures too close. The planet doesn't just deflect asteroids and comets, it captures them in gravitational death spirals that tear objects apart atom by atom before consuming their remains. Juno's atmospheric analysis detected the chemical signatures of countless destroyed worlds, including metallic traces that suggest entire moonlets have been devoured over millions of years. Dr. Heidi Hamel from the Association of Universities for Research in Astronomy calls Jupiter a cosmic meat grinder that processes solar system debris with terrifying efficiency. The planet's tidal forces are so intense they can shred objects hundreds of kilometers across, turning solid bodies into streams of molten rock and metal. Juno witnessed several small asteroids meet this fate, documenting their final moments as they spiraled into Jupiter's crushing embrace. The gravity well extends far beyond Jupiter itself. Objects passing within 2.5 million kilometers begin experiencing tidal stress that eventually proves fatal. What's most disturbing is the sheer scale of destruction. Juno's chemical analysis suggests Jupiter has consumed thousands of large objects throughout its history, including bodies that might have supported primitive life. Each impact adds to Jupiter's mass and energy, making it an ever-growing cosmic vacuum cleaner that grows more powerful with each meal. The planet's protective role comes with an appetite that never stops growing. Great red spot shrinking. The most iconic feature in our solar system is dying, and its death throes might be more catastrophic than anyone imagined. Juno's precise measurements confirmed the Great Red Spot is shrinking at an accelerating rate, having lost over 50% of its size since the 1800s. At current rates, this 400-year-old storm system could vanish completely within 20 years. But here's the terrifying part. As it shrinks, it's becoming more intense, like a cosmic pressure cooker building toward an explosive finale. Wind speeds within the shrinking storm have increased to over 650 kilometers per hour, creating conditions more violent than anything previously recorded on Jupiter. Dr. Glenn Orton at NASA's Jet Propulsion Laboratory warns that the spot's collapse could trigger massive atmospheric upheavals across Jupiter's entire hemisphere. The shrinking process appears irreversible, driven by changes in Jupiter's deep circulation patterns that Juno is still struggling to understand. As the Great Red Spot contracts, it's pulling material from deeper atmospheric layers, concentrating energy and chemical compounds in ways that could destabilize surrounding weather systems. Computer models attempting to predict the spot's final collapse consistently crash, unable to process the extreme conditions created by the dying storm. What happens when 4 centuries of accumulated atmospheric energy gets released all at once? Juno might be positioned to witness the most violent planetary weather event in recorded history, the death of a storm so massive it has shaped Jupiter's appearance for longer than humans have been studying the planet. So there you have it, Jupiter's most terrifying secrets revealed by Juno's groundbreaking mission. From impossible storm formations to the dying Great Red Spot, our solar system's giant is far more mysterious and dangerous than we ever imagined. These discoveries are just the beginning of what Simply Science brings you every week. If these cosmic revelations blew your mind, smash that subscribe button and hit the bell icon so you never miss our latest space discoveries. What shocked you most about Jupiter's hidden mysteries? Drop your thoughts in the comments below. I read every single one. Until next time, keep questioning the universe. What if humanity's first contact with alien technology already happened, and we almost missed it? In October 2017, a mysterious cigar-shaped object from deep space blazed through our solar system at 87.71 kilometers per second, faster than any natural object should move. Scientists called it Oumuamua, meaning scout from afar. But here's the kicker, this thing accelerated away from the sun without any visible propulsion, breaking every law of physics we know. Did you know that some Harvard scientists seriously believe we just witnessed our first alien spacecraft? Oumuamua initial detection. On October 19, 2017, the cosmos delivered humanity its first confirmed interstellar visitor, and Robert Warwick at the Pan-STARRS, one telescope in Hawaii, was the lucky astronomer to spot it first. But this wasn't your typical space rock discovery. Oumuamua was already 33 million kilometers away from Earth when we finally noticed it, traveling at speeds that, honestly, just screamed alien highway. The object had performed its closest solar flyby on September 9, 2017, coming within 38 million kilometers of our Sun before we even knew it existed. Its hyperbolic trajectory told an incredible story. This visitor had traveled through the dark void between stars for potentially millions of years before stumbling into our cosmic neighborhood. The Hawaiian name Oumuamua means scout or messenger from afar arriving first, and boy did it live up to that name. What made this discovery earth-shattering wasn't just its interstellar origin. It was moving too fast for our Sun's gravity to capture it permanently, meaning we had only a brief window to study this cosmic time capsule before it vanished back into the infinite darkness between stars. The detection itself was almost miraculous timing. Oumuamua was already on its way out of our solar system when spotted, having reached its perihelion weeks earlier. The astronomical community immediately recognized this as a once-in-a-lifetime opportunity to study pristine material from another star system, triggering an unprecedented international observational campaign. Within days of discovery, telescopes worldwide were trained on this mysterious visitor, desperate to gather as much data as possible before it faded beyond detection limits forever. Classification challenges. Scientists love putting things in neat categories, but Oumuamua laughed in the face of their organizational systems. Initially tagged as Comet C 2017 U1 due to its hyperbolic escape trajectory, astronomers expected to find the telltale fuzzy coma that forms when comets heat up near the Sun. Instead, they found absolutely nothing. No gas, no dust, no glowing halo whatsoever. This forced an immediate reclassification to asteroid A 2017 U1, but even that didn't stick. Once confirmed as definitively interstellar in origin, it earned the historic designation 1I 2017 U1, literally the first official member of an entirely new category, interstellar objects. This classification nightmare reflected something deeper and more unsettling. Oumuamua didn't behave like any known comet or asteroid in our solar system. It was forcing scientists to create new categories because existing ones simply couldn't contain its strangeness. The International Astronomical Union had to scramble to establish naming conventions for objects that, until 2017, existed only in theoretical papers. This classification chaos was just the beginning of Oumuamua's assault on conventional astronomical wisdom, setting the stage for discoveries that would challenge everything we thought we knew about how objects behave in space. The unprecedented situation required emergency sessions among astronomical organizations to establish proper nomenclature protocols. Minor Planet Center Director Gareth Williams worked around the clock to coordinate the classification process, while researchers debated whether traditional comet-asteroid distinctions even applied to interstellar visitors. The object's refusal to fit existing categories forced a fundamental reimagining of how we classify celestial bodies, acknowledging that our solar system's objects might represent just a tiny fraction of the diversity that exists in interstellar space. Trajectory analysis. When Oumuamua entered our solar system, it didn't follow any ordinary orbital mechanics playbook. This interstellar intruder approached from north of the ecliptic plane at an extreme angle, suggesting it originated from the direction of the bright star Vega in the constellation Lyra. As it screamed toward the Sun, Oumuamua accelerated to an absolutely mind-bending 87.71 kilometers per second, fast enough to circle Earth's equator in just over 7 minutes. The Sun's immense gravitational field acted like a cosmic slingshot, bending the object's trajectory into a sharp northward curve during its closest approach at 0.255 astronomical units, approximately 17% closer to the Sun than Mercury ever ventures. This gravitational dance launched Oumuamua on an escape trajectory toward the constellation Pegasus, ensuring it would leave our solar system forever. But here's what made trajectory analysts lose sleep. The object's path showed subtle deviations that couldn't be explained by gravitational forces alone. These tiny but measurable course corrections suggested something was pushing Oumuamua in ways that defied Newton's laws. The trajectory data painted a picture of an object under the influence of mysterious forces that would later become the center of heated scientific debates about alien technology versus exotic natural phenomena. Detailed orbital calculations revealed that Oumuamua had likely been wandering through interstellar space for hundreds of millions of years before its chance encounter with our solar system. The object's orbital eccentricity of approximately 1.2 marked it as definitively unbound to our Sun. while its inclination of about 122 degrees indicated it was traveling nearly perpendicular to the plane of our solar system. NASA's Jet Propulsion Laboratory continuously refined trajectory predictions as new observations poured in, but the mounting evidence of non-gravitational forces would soon turn routine orbital mechanics into one of astronomy's greatest puzzles. Photometry and shape analysis. Nothing had prepared astronomers for Oumuamua's absolutely bizarre light curve behavior. As this cosmic enigma tumbled through space with a 7.3-hour rotation period, its brightness varied by an unprecedented factor of 10, meaning it alternated between being 10 times brighter and 10 times dimmer as it spun. No known asteroid or comet in our entire solar system exhibits such extreme brightness variations. The only way to explain this dramatic light show was if Oumuamua possessed an incredibly elongated shape, possibly 10 times longer than it was wide, resembling a cosmic cigar or needle. Some models suggested even more exotic geometries, with dimensions potentially reaching 240 meters wide by 1,080 meters long, or alternatively, a pancake-shaped object of similar proportions. The Webb Space Telescope observations provided crucial constraints, indicating the object's surface was surprisingly reflective, about 4 times more reflective than typical asteroids. This high albedo suggested either an unusual composition or a surface coating of some kind. The extreme aspect ratio challenged everything scientists understood about how celestial bodies form and evolve. Natural processes typically create relatively spherical objects due to gravitational forces, yet Oumuamua appeared to violate these fundamental principles. Its shape was so unusual that some researchers began seriously considering whether natural formation processes could even produce such an object, opening the door to more exotic explanations. Acceleration anomaly. June 27, 2018 marked the day that Oumuamua officially broke physics, or at least appeared to. Marco Michelli and his team published observations showing that this interstellar visitor was accelerating away from the Sun in a way that gravity alone couldn't explain. The non-gravitational acceleration was subtle but undeniable, changing the object's velocity by approximately 17 meters per second over the observation period. For any normal comet, this would be easily explained by outgassing, when solar heat vaporizes ice, creating jets that act like tiny rocket engines. But Oumuamua had already proven it wasn't normal by showing zero signs of a coma or tail. The acceleration was detected through precise astrometric measurements that tracked the object's position against background stars with incredible accuracy. The force appeared to be acting radially away from the Sun, similar to solar radiation pressure, but Oumuamua would need to be impossibly lightweight or have an impossibly large surface area for photons alone to push it around. This discovery sent shockwaves through the astronomical community because it suggested either exotic physics or exotic origins. The acceleration magnitude was tiny, about 5 times 10 to the minus 6th meters per second squared, but measurable enough to rule out observational error. Scientists found themselves facing an object that was simultaneously too dense for radiation pressure and too inactive for typical cometary outgassing, creating a perfect storm of confusion. Spitzer observations. The Spitzer Space Telescope became humanity's detective in the case of the missing Oumuamua. During November 2017, this infrared space observatory stared at the object's predicted location for over 30 continuous hours, searching for any thermal emission that would reveal its true size and composition. The result? Absolutely nothing. This non-detection wasn't a failure, it was actually a goldmine of information that deepened the mystery exponentially. Spitzer's inability to see Oumuamua placed strict upper limits on the object's thermal emission, which in turn constrained its size to no larger than 440 meters in its longest dimension, assuming typical asteroid-like properties. More importantly, the lack of detectable heat signature ruled out significant amounts of carbon monoxide, carbon dioxide, and dust production, the typical calling cards of active comets. This observation was crucial because it eliminated many conventional explanations for the mysterious acceleration. If Oumuamua wasn't producing detectable amounts of gas or dust, then what invisible force was pushing it around? The Spitzer data also suggested the object's surface temperature was consistent with a dark, possibly organic-rich composition, similar to the outer solar system objects. Yet this composition didn't match the high reflectivity observed at visible wavelengths, creating another layer of contradiction. The telescope's failure to detect the object directly contributed to size estimates and ruled out many exotic composition theories, but it also eliminated easy explanations for the acceleration anomaly, pushing scientists toward increasingly creative theoretical solutions. Artificial origin hypothesis. Abraham Avi Loeb, Harvard's controversial astrophysicist, dropped a bombshell that sent ripples through both scientific circles and popular media. In his 2018 paper and subsequent 2021 book Extraterrestrial, Loeb argued that Oumuamua's unique characteristics, its extreme elongated shape, unusual reflectivity and mysterious acceleration, could only be satisfactorily explained if it were an artificial object created by an alien civilization. Specifically, Loeb proposed that Oumuamua might be a light sail, which is, an ultra-thin sheet of material designed to be pushed by stellar radiation for interstellar travel. This technology, while still theoretical for humans, could explain both the object's extreme thinness, giving it that unusual aspect ratio, and its acceleration away from the sun via solar radiation pressure. The hypothesis suggested we might have witnessed discarded alien technology or even an active probe sent to investigate our solar system. Loeb's argument wasn't based on wild speculation but on systematic elimination of conventional explanations. He calculated that for solar radiation pressure to account for the observed acceleration, Oumuamua would need to be incredibly thin, perhaps only millimeters thick, which could occur naturally only under the most extraordinary circumstances. The artificial origin hypothesis sparked fierce debate, with most astronomers maintaining that extraordinary claims require extraordinary evidence. However, Loeb's rigorous mathematical approach forced the scientific community to seriously consider possibilities that had previously been relegated to science fiction, fundamentally changing how we approach anomalous observations. Dark comet theory. Enter the dark comet theory, the scientific community's attempt to rescue Oumuamua from alien conspiracy theories while still explaining its impossible behavior. Alan Fitzsimmons and his colleagues proposed that Oumuamua represents a new class of object comets that have been so heavily processed by cosmic radiation and interstellar weathering that they've lost their ability to produce visible comas and tails. The theory suggests that during its millions-year journey through interstellar space, Oumuamua was bombarded by high-energy particles that altered its surface composition and internal structure. This processing could have created a carbonaceous crust that insulates the interior while still allowing subtle outgassing of invisible materials like hydrogen gas. In 2023, Jennifer Bergner and Daryl Seligman published groundbreaking research showing that cosmic ray bombardment of water ice can produce trapped molecular hydrogen that later escapes when heated by the sun. This hydrogen outgassing would be completely invisible to telescopes, but could generate enough force to explain the observed acceleration. The beauty of this theory is that it explains not just the acceleration anomaly, but also why Oumuamua appeared so different from familiar comets. The dark comet model suggests that interstellar space is filled with these ghostly, processed remnants of ancient planetary systems. Objects that look dead but retain just enough activity to push themselves around when they encounter a star's heat and light. Dark comet classification. The dark comet classification emerged as astronomers realized that Oumuamua might not be unique, but rather the first detected member of an entirely new category of celestial objects. These dark comets are defined as objects that exhibit non-gravitational acceleration, the smoking gun of outgassing activity, without displaying any visible signs of cometary behavior like comas, tails, or dust production. The classification system divides these mysterious objects into categories based on their size and orbital characteristics. Large dark comets like Oumuamua follow hyperbolic trajectories and likely originate from interstellar space, while small dark comets remain gravitationally bound within our solar system. Recent discoveries have identified several potential dark comet candidates within our own solar system, including objects like 2003 RM and 2005 VL1, which show subtle acceleration signatures without obvious cometary activity. The classification represents a fundamental shift in how astronomers categorize solar system objects, acknowledging that the traditional asteroid-comet dichotomy is insufficient to describe the full diversity of objects in space. dark comets challenge our understanding of planetary formation and evolution, suggesting that the boundaries between different types of celestial bodies are far more fluid than previously believed. This new classification system also has profound implications for planetary defense strategies, as dark comets might be more difficult to detect and track than traditional objects, yet their unpredictable acceleration could alter their trajectories in unexpected ways. Scientific debate. The scientific community remains locked in a fascinating intellectual battle over Oumuamua's true nature, with competing theories each addressing some aspects of the mystery, while leaving others unexplained. The mainstream scientific consensus, established by July 2019, favors natural explanations, with the hydrogen outgassing model gaining significant support following Bergner and Seligman's 2023 research. This theory elegantly explains both the acceleration and the lack of visible outgassing through cosmic ray processing of interstellar ice. However, alternative explanations persist, including nitrogen ice composition models proposed by Alan Jackson and Stephen Desch, which suggest Oumuamua might be a fragment of a Pluto-like exoplanet. The artificial origin hypothesis championed by Avi Loeb continues to attract attention despite mainstream rejection, particularly given the lack of definitive proof for any natural explanation. Some researchers propose even more exotic scenarios, including dust bunny models where Oumuamua could be an extremely low-density aggregate held together by electrostatic forces. The debate has highlighted crucial gaps in our understanding of interstellar object formation and evolution. The upcoming Vera Rubin Observatory, scheduled to begin full operations in the mid-2020s, promises to detect hundreds or thousands of similar objects, potentially providing the statistical sample needed to resolve the debate. Meanwhile, ESA's proposed Comet Interceptor mission could potentially visit another interstellar visitor if one arrives at the right time. The scientific controversy surrounding Oumuamua has already advanced our understanding of solar system formation, interstellar space conditions, and the importance of rapid response observations for transient celestial phenomena, regardless of which theory ultimately proves correct. That's the incredible story of Oumuamua, our first confirmed interstellar visitor that continues to challenge everything we thought we knew about space. From its mysterious acceleration to its impossible shape, this cosmic enigma proves that the universe still holds secrets we're only beginning to understand. What do you think Oumuamua really was? Natural phenomenon or something more extraordinary? Drop your theories in the comments below. I'd love to hear your thoughts. If you enjoyed diving into this cosmic mystery, hit that subscribe button and ring the bell icon to never miss another mind-bending episode from Simply Science. Until next time, keep looking up. In September of 2022, humanity officially became a cosmic force, capable of moving celestial objects through space. But what happened next, honestly, shocked even NASA's top scientists. When the DART spacecraft slammed into asteroid Dimorphos at 14,000 miles per hour, it didn't just nudge the space rock as planned. The impact created a 32-minute orbital change instead of the expected 10 minutes, proving our planetary defense technology is 3 times more powerful than we ever imagined. We didn't just deflect an asteroid, we revolutionized physics itself. The DART mission. What if I told you that on a Tuesday morning in September 2022, humanity officially became a space cowboy? That's exactly what happened when NASA's DART spacecraft smashed into asteroid Dimorphos at over 14,000 miles per hour, marking the first time our species deliberately changed the course of a celestial object. This wasn't just another space mission, this was our planetary defense debut. The double asteroid redirection test launched in November 2021 with one clear mission: prove we could knock an asteroid off course if one ever threatened Earth. Scientists chose Dimorphos, a football stadium-sized moon orbiting the larger asteroid Didymos, as the perfect target. Why? Because it was far enough away to be safe but close enough for telescopes to measure the results. The $325 million mission spent nearly a year traveling through space, guided by autonomous navigation systems that would steer the spacecraft into its target without human intervention. On September 26, 2022, at exactly 7:14 p.m. Eastern Daylight Time, DART completed its kamikaze mission, streaming live images back to Earth until the very moment of impact. Ground control erupted in cheers as confirmation arrived. Humanity had just taken its first real step toward becoming a spacefaring civilization capable of defending our home planet from cosmic threats. Impact results analysis. You know that moment when you throw a rock into a calm pond and watch the ripples spread? Well, multiply that by about 10 billion and you'll get close to what happened when DART hit Dimorphos. The moment of impact on September 26, 2022 created the most spectacular light show in our solar system, a massive debris plume that stretched over 10,000 kilometers into space, visible to telescopes across the globe. But here's the mind-blowing part. This wasn't just a little puff of dust. The impact crater ejected millions of tons of rock and debris at speeds reaching 500 meters per second, creating what scientists called a comet-like tail that persisted for months. Ground-based observatories and the Hubble Space Telescope captured breathtaking images, showing the asteroid system glowing like a distant star. The brightness increase was so dramatic that Dimorphos became 35 times brighter than normal, making it visible to amateur astronomers with basic equipment. What shocked researchers most was the duration of the debris cloud. Initial models predicted it would dissipate within days, but observations in November 2022 still showed active particle ejection. The European Southern Observatory tracked individual boulders the size of cars being hurled into space, while NASA's infrared telescopes detected the heat signature of the impact site glowing for weeks afterward. This spectacular aftermath proved that kinetic impact missions create far more dramatic and long-lasting effects than anyone had calculated. Momentum enhancement discovery. Scientists expected a gentle nudge. What they got was a cosmic sledgehammer effect that rewrote the laws of asteroid physics overnight. When NASA's mission planners originally calculated DART's impact, they predicted the collision would slow Dimorphos by exactly 10 minutes in its 11.9-hour orbit around Didymos. Conservative estimates based on laboratory simulations and computer models suggested this would be humanity's modest first step into planetary defense. But on October 11, 2022, when ground-based radar measurements finally confirmed the results, jaws dropped across the scientific community. The asteroid's orbital period had decreased by a staggering 32 minutes, more than triple the expected change. This wasn't just beating expectations, this was obliterating them. The momentum transfer efficiency reached 2.2 to 4.9 times higher than theoretical predictions, depending on which measurement method scientists used. Dr. Lori Glaze from NASA's Planetary Science Division called it a game-changing discovery that fundamentally altered our understanding of kinetic impactor technology. The reason? Dimorphos wasn't behaving like a solid rock, but more like a loose aggregate of boulders held together by weak gravity. When DART struck at 6.14 kilometers per second, it didn't just transfer its momentum, it triggered a massive recoil effect, as tons of debris shot out like a natural rocket thruster. This ejecta enhancement meant that future asteroid deflection missions could work with much smaller spacecraft than previously thought, revolutionizing our entire approach to planetary defense. Asteroid structure insights. Ever wondered what happens when you punch a pile of gravel versus a solid brick wall? That's exactly what DART's collision revealed about Dimorphos, and honestly, it completely shattered our assumptions about asteroid composition. Before September of 2022, scientists believed most asteroids were dense, rocky bodies that had formed billions of years ago during the early solar system. But when DART slammed into Dimorphos at 14,000 miles per hour, the impact didn't create the expected solid crater. Instead, it triggered what researchers called a catastrophic disruption that exposed the asteroid's true nature as a gravitationally bound rubble pile. High-resolution images from ground-based telescopes showed massive boulders, some the size of school buses, being ejected from the impact site, revealing that Dimorphos is essentially a loose collection of rocks held together by extremely weak gravitational forces. This discovery revolutionized our understanding of near-Earth objects, with Dr. Andy Rivkin from Johns Hopkins Applied Physics Laboratory confirming that 80% of asteroids in our cosmic neighborhood share this rubble pile structure. The implications are, well, staggering. These flying gravel heaps are much easier to deflect than solid asteroids, but they're also way more unpredictable in how they respond to impacts. Spectroscopic analysis conducted in late 2022 revealed that the ejected material contained primitive carbonaceous compounds dating back 4.6 billion years, making Dimorphos a time capsule from the solar system's violent birth. This insight means future deflection missions will need completely different strategies depending on whether they're targeting solid asteroids or these cosmic rubble piles. Strategic implications. What happens when humanity suddenly realizes it can literally move mountains in space? The moment DART's success was confirmed in October 2022, every space agency on Earth started rewriting their planetary defense playbooks. This wasn't just a scientific achievement, it was a species-level upgrade that transformed us from sitting ducks to active defenders of our cosmic neighborhood. The 32-minute orbital change proved that kinetic impactor technology could work with dramatically smaller spacecraft than previously calculated, meaning we could launch multiple deflection missions for the cost of one original estimate. NASA's Planetary Defense Coordination Office immediately began updating their threat assessment protocols, realizing that asteroids once considered too large to deflect were now manageable targets. But the implications go far beyond just Earth protection. International space treaties from the 1967 Outer Space Treaty suddenly needed modernization. Who has the authority to deflect an asteroid that might affect multiple countries? ESA's Director General Josef Aschbacher announced in early 2023 that the success had accelerated European Union space defense initiatives by at least 5 years. Meanwhile, China's National Space Administration and Russia's Roscosmos both fast-tracked their own asteroid deflection programs, creating a new space race focused on planetary protection rather than exploration. The most surprising strategic shift came from commercial space companies like SpaceX and Blue Origin, who began developing rapid response deflection systems that could be deployed within 18 months of asteroid detection, turning planetary defense from a decades-long project into something resembling an emergency response system. We officially entered the era where extinction-level threats became manageable engineering problems. Hera mission planning. What do you do when you've just pulled off humanity's greatest cosmic billiard shot and need to see the damage up close? You send in the forensic investigators. That's exactly what ESA's Hera mission represents, a $129 million space detective story launching in October 2024 to examine DART's crime scene with unprecedented detail. While DART was the muscle, Hera is the brains, equipped with advanced imaging systems and 2 CubeSat companions called Juventus and Milani that will map every crater, boulder, and debris trail left behind by the September 2022 impact. The mission will spend 2 years traveling to the Didymos system, arriving in late 2026 to conduct the most thorough asteroid autopsy in human history. Hera's instruments include high-resolution cameras, laser altimeters, and ground-penetrating radar that will create 3-dimensional maps showing exactly how Dimorphos deformed during impact. But here's where it gets fascinating. Juventus will actually land on Dimorphos and drill into its surface, analyzing the internal structure that made DART's momentum transfer so surprisingly effective. Meanwhile, Milani will study the dust environment and track particles still orbiting the asteroid system 4 years after impact. ESA's mission planners designed Hera to answer the biggest question: can we scale up this technology for real planetary threats? The data collected will feed directly into NASA's next-generation deflection systems, creating a complete blueprint for asteroid defense architecture. When Hera arrives at Didymos, it won't just be studying the past, it'll be engineering humanity's cosmic security system for the future. Planetary defense evolution. Remember when humanity's biggest space worry was whether satellites would crash into each other? Those days, honestly, officially ended when DART proved we could weaponize physics itself against cosmic threats. The September 2022 success didn't just validate one mission, it triggered a complete evolutionary leap in how our species approaches planetary defense. Within months of impact confirmation, space agencies worldwide began developing second-generation deflection technologies that frankly make DART look like a prototype. NASA's follow-up missions now include multiple kinetic impactors working in coordinated strikes, gravity tractors for precision orbit adjustments, and even nuclear pulse units for the most extreme scenarios. Japan's JAXA announced their 2028 Hayabusa X mission will test precision drilling techniques to alter asteroid rotation, while India's ISRO is developing swarm deflection technology using dozens of small spacecraft acting as a collective force. The most revolutionary change, though, came from private sector involvement. SpaceX began designing Falcon Heavy variants specifically for rapid asteroid response, cutting deployment time from years to months. ESA's 2025 Planetary Defense Conference established the International Asteroid Response Protocol, creating standardized procedures for global cooperation during real threats. But perhaps the biggest evolution is philosophical. We've shifted from reactive astronomy to proactive cosmic engineering. Ground-based surveys like NASA's NEO Surveyor and ESA's Fly-Eye telescopes now operate as early warning systems feeding directly into automated deflection networks. What started as humanity taking its first baby steps into planetary defense has evolved into a sophisticated cosmic immune system that actively monitors and neutralizes threats before they become extinction events. Mission success redefinition. When was the last time scientists had to completely rewrite what winning means in the middle of celebrating victory? Well, that's exactly what happened when DART's results came back showing a 32-minute orbital shift instead of the predicted 10 minutes. Suddenly, every planetary defense mission in development had to recalibrate their success metrics. Before October 2022, mission planners used these pretty conservative models based on solid asteroid physics and laboratory impact tests that assumed only modest momentum transfer rates. NASA's original benchmarks actually classified anything above 73 seconds of orbital change as a complete success, making DART's 32-minute achievement an almost 2,600% overperformance. This unexpected triumph forced JPL engineers to completely revise their deflection calculators and threat assessment algorithms. Dr. Tom Statler from NASA headquarters even admitted that success parameters for future missions like ESA's Hera and NASA's proposed NEO interceptor needed fundamental restructuring. The ripple effects were immediate asteroid deflection timelines that once required decades of advance warning could now work with just years of preparation. International space law committees had to redefine minimum deflection requirements for planetary protection protocols, while commercial space contractors realized they could bid for asteroid deflection contracts using much smaller, cheaper spacecraft. Most importantly, the scientific community learned that real-world asteroid physics operated on completely different principles than computer simulations suggested. Mission success was no longer about hitting predetermined targets. It was about adaptive engineering that could harness these unexpected physical phenomena. DART didn't just succeed, it redefined success itself, proving that sometimes the best victories are the ones that exceed every prediction and force humanity to dream bigger. Debris management and safety concerns. What happens when you create the largest artificial debris field in human history and suddenly realize it might come back to haunt you? That's the uncomfortable question NASA scientists faced when DART's impact on September 26, 2022 scattered millions of tons of asteroid fragments across space at velocities reaching 500 meters per second. While everyone celebrated the 32-minute orbital success, space debris experts quietly began tracking what they called the Dimorphos particle cloud, an expanding sphere of rocky projectiles that could pose risks to future spacecraft missions. ESA's Space Debris Office immediately activated enhanced tracking protocols using ground-based radar systems to monitor the largest fragments, some weighing several tons, and traveling on unpredictable trajectories. The October 2022 debris analysis revealed that particles were spreading far beyond the Didymos system, with some fragments potentially reaching Earth-crossing orbits within decades. Commercial satellite operators like SpaceX and OneWeb began incorporating DART debris models into their collision avoidance systems, while NASA's Orbital Debris Program Office updated their space traffic management protocols to account for artificial asteroid fragmentation. The most concerning discovery came in early 2023 when optical telescopes detected boulder-sized chunks still being ejected from Dimorphos months after impact, suggesting the asteroid was experiencing ongoing structural collapse. International Space Station mission planners now include DART debris assessments in their orbital safety calculations, and future asteroid deflection missions must prove they won't create navigational hazards for deep space exploration. The irony is pretty striking. Humanity's first successful planetary defense created our first interplanetary pollution problem. Precision requirements for real threats. What good is humanity's newfound cosmic billiard skills if we can't hit the balls that actually matter? While DART's triumph against Dimorphos was spectacular, deflecting a real Earth-threatening asteroid requires precision levels that make Swiss watchmaking look like finger painting. The sobering reality hit scientists in early 2023 when they calculated the exact requirements for real planetary defense scenarios. Unlike Dimorphos, which was a harmless test target 11 million kilometers away, an actual extinction-level asteroid would need deflection decades before impact, and missing by even 0.01% could mean the difference between a near miss and global catastrophe. NASA's Planetary Defense Office revealed that successful deflection of a 1-kilometer asteroid discovered just 10 years before Earth impact would require trajectory accuracy within 10 meters at the moment of collision. Imagine threading a needle while blindfolded and riding a rocket. The challenge multiplies when dealing with fast-rotating asteroids or binary systems like Didymos, where gravitational interactions can amplify small errors into massive miscalculations. ESA's trajectory modeling in 2024 showed that deflecting Apophis during its 2029 close approach would demand navigation precision exceeding anything achieved in human spaceflight history. Perhaps most daunting, detection systems like NASA's NEOWISE and the upcoming NEO Surveyor must provide asteroid composition data, rotation periods, and structural characteristics years in advance because with real threats there are no second chances. DART proved we can move asteroids, but defending Earth means hitting cosmic bullseyes with zero margin for error. And that's how humanity officially became cosmic defenders in just one incredible impact. From DART's sledgehammer effect to the 32-minute orbital miracle, we've proven that extinction-level threats are now manageable engineering problems. But this is just the beginning of our planetary defense evolution. What amazed you most about DART's discoveries? Drop your thoughts in the comments below. I read every single one. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science breaking down the universe's most incredible mysteries. Until next time, keep exploring.